Okay, in this video we have a pump. This pump is faulty. It was stripping out the electrics, so it's going out on overload. I don't exactly know what's wrong with it. We're going to be taking it apart and looking at testing it in a different video. But for now, we're just going to look over the different parts of the pump and just talk about what it does, the function and functionality and stuff like that. So this is used to pump coolant it was used to pump coolant on a saw. So electric motor at the top, similar sort of thing to this, but smaller. Three-phase electric supply. So you've got your L1, L2, L3, whichever way they are, connected to a three-phase contactor or an inverter or a variable frequency drive, which we have one of here. So it could be connected to one of these, variable frequency drive, with your phases U, V and W coming out the bottom. This one is single phase to three phase, so it's just L1 and neutral at the top, and three phases coming out. This will give you variable speed control, torque settings, overload, a better control over overload protection than a standard electrical contactor, and so these are a lot more efficient as well. So you'll see these are a lot more common to be used in motor control circuits than a contactor that would have been used the majority of the time years ago. Okay, so we've discussed the drive. We've got this sits into the coolant or the material that you're going to be pumping, the liquid, and the pump base is on there. It spins around and it will draw the fluid up here and out here. Electric motor on the top, as we've discussed. This generates your rotation, which then through this shaft here rotates the pump at the bottom. So we can already feel, so one of the problems with this, we can feel that is a little bit grumbly. It should be, ideally it wants to be really smooth. Doesn't feel to be any play in there, but it's clearly seen better days. It's pretty disgusting. It's not had a lot of maintenance. It's not been looked after. And this is often what can lead to failure modes developing, whether it's the bearings that have failed, or the pump has failed, or in the motor itself, one of the windings could have gone down. That could be caused by overheating, by too much dirt and dust build up. There's no cooling fins on here, so you might notice this here, the direction arrow. There's a direction arrow there that'll tell you the direction of the pump. That is important for actually making the pump efficiently, and sometimes pump at all. Direction we're going to discuss in another video, but direction can be controlled by your windings. If you want it to change direction, you basically swap two windings. We'll go into more detail about that and how that works and why it works in another video. What we're just going to do now is disconnect the pump base if we can. Luckily it's not seized on. We're going to have a look at the pump. So you can see a kind of filter strainer mechanism in the bottom there. That is to stop the majority of dirt, contamination, swarf, etc. that could be being pulled into the pump. And this is the pump. So this, you can feel this doesn't feel very good. So what we've got here is a centrifugal pump, and basically it generates, it doesn't sound very good at all, it generates a rotational force on the fluid, and it will basically push it up this pipe here and out here. It's a pretty basic sort of pump, but relatively common. This doesn't need to be anything particularly special. It is just pumping a fluid out of the pipe and into the blade of the saw to keep coolant onto the blade. So I can't really see how to take this off at the moment. So at the moment I think we're going to leave that as it is.